Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have this is nice radical equation. So you see that inside the radical sign we have k to the power of 6 is equals to in the right hand side. Inside the square root sign we have 3 to the power of 6. So we need to find all the roots of this equation. You see that this is the sixth order equation and we know about that this equation has 6 or less than or equals to 6 roots. We need to find all that roots of this equation. So here first we need to remove the radical sign from both of the sides. So for this we will just take here squaring on both of the sides, and when we apply squaring this will be written as in this form. Further you see here we have this 2 and this square root are gone, and we obtain k to the power of 6 is equals to this 2 and this square root are also gone, and we get 3 to the power of 6. So here further you see that this equation will become sixth order equation. So we move the term 3 to the power of 6 from right hand side to the left hand side, and we get k to the power of 6 minus 3 to the power of 6, and this whole equation is equals to 0. So we rewrite this equation as we write k to the power of 6 as k cubed and its whole square, minus we write 3 to the power of 6 as 3 cubed and its whole square, and this is equals to 0. So further we use here the nice square identity. You know about that we have a square minus b square equals to a minus b times of a plus b. So first we use this nice algebraic formula here, and according to this formula we write the above equation as k cubed minus 3 cubed times k cubed plus 3 cubed, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write k cubed minus 3 cubed equals to 0, and the second case is we write k cubed plus 3 cubed equals to 0. So here we call that this is the equation number 1 and this is our equation number 2. So we just solve both of these two equations and we get the values of k. So in equation number 1 we use here this nice cubic formula. You know about that if we have a cubed minus b cubed equals to a minus b times of a square plus ab plus b square. So according to this nice formula, we just expand the equation number 1 as this is k cubed minus 3 cubed becomes here k minus 3 times of k square plus k into 3 plus 3 square, and this whole equation is equals to 0. And now further in the next step we divide this equation into the two cases. The first case is we write k minus 3 is equals to 0, and the second case is we write k square plus 3k plus 3 square becomes 9, and this whole equation is equals to 0. From here we move minus 3 to the right hand side and we get the value of k is equals to plus 3, and you see that this is the quadratic equation, and we just apply here the nice quadratic formula to solve this quadratic equation. And for this first we write the coefficients of this equation, and its coefficients are a equals to 1, b equals to 3, and c equals to 9. And we state the quadratic formula as k equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. So this is the our quadratic formula, and here we substitute all the values of a, b and c, and we get k is equals to the value of b is 3 becomes minus 3 plus minus square root of b square, and it is 3 square minus 4 times of a is 1, and c is 9 and it is divided by 2 times of a, and here our a is equals to 1. So further in the next step we have k is equals to minus 3 plus minus this is 3 square becomes 9 minus 4 times of 9 divided by 2 times of 1 equals to 2. So inside the square root sign we just take common 9 from here, and when we take common 9 we get the remaining values are 1 minus 4, and it is divided by 2. So further in the next step here we need more simplifications, and you see that inside the square root sign we have minus 3 plus minus. You know that square root of 9 becomes 3, and 1 minus 4 becomes square root of minus 3, and it is divided by 2. So this equation becomes minus 3 plus minus 3 times of square root of 3 into, we know that square root of minus 1 becomes iota, and it is divided by 2. These are the other two complex roots of the given equation, which we get here from equation number 1. So in the same pattern, we just solve equation number 2, so that in equation number 2 we apply here this nice formula. A cubed plus b cubed equals to a plus b times of a square minus ab plus b square. According to this formula, we just simplify the equation number 2 as, first we copy down here, it is k cubed plus 3 cubed equals to 0, and now we apply the above formula here and we get k plus 3 times of k square minus k times of 3 plus 3 square, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write k plus 3 is equals to 0, and the second case is we write k square minus 3k plus 9 is equals to 0. So from here we move plus 3 to the right hand side and we get the value of k is equals to minus 3. This is the fourth root of the given equation, and in order to get the other roots we need to simplify this quadratic equation, and here we again apply the quadratic formula, and for this we write its coefficients are a is equals to 1, b equals to minus 3, and c is equals to 9. And we state the quadratic formula as k equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. And we state the quadratic formula as k equals to minus b, the value of b is minus 3 plus minus square root of b square, it is minus 3 square minus 4 times of a is 1, and c is 9, and it is divided by 2 times of a, and here our a is equals to 1. Further we have minus times minus becomes plus 3 plus minus square root of minus 3 square becomes 9 minus 4 times of 9 divided by 2 times of 1 is equals to 2. And in the next step we have 3 plus minus, inside the square root sign we take common 9, and when we take common 9 we get the remaining values are 1 minus 4, and it is divided by 2. So here we simplify the terms and we get this is 3 plus minus. Here we apply square root separately on both of these two values and we get square root of 9 into square root of 1 minus 4 becomes minus 3, and it is divided by 2. And in the next step we have k is equals to 3 plus minus. We know that square root of 9 becomes 3 into square root of 3, and we know about that square root of minus 1 becomes iota, and it is divided by 2. So here we will just get there are 6 roots of the given equation, and these 6 roots are, we get the real roots are k1 is equals to 3 and k2 is equals to minus 3. These are the two real roots, and k3 is equals to minus 3 plus square root of 3 square root of 3 times square root of 3 iota divided by 2. This is the second complex root, and k4 is equals to minus 3 times of square root of 3 iota divided by 2. This is the fourth root. K5 is equals to 3 plus 3 times square root of 3 iota divided by 2, and k6 is equals to 3 minus 3 times of square root of 3 iota divided by 2. So these are the 6 roots of the given equation, and this is the our final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.